All right, guys. So yesterday we finished up with this problem, working on the upper and lower sum of the region. And again, the beginning part is not that hard. It's all that reduction that you have to do. And it's not that it's hard reduction, it's just forever. Does that make sense? It just takes a long time. So it's just time. So we're going to keep going with this, and then we're even going to talk about like area and stuff like that. So the previous example illustrates some important things about lower and upper sums. First, notice that for any value of n, the lower sum is less than or equal to the upper sum. A bit bigger for them. Sorry. So our lower sum, remember the only difference in our answers was that one had a minus in it, the other one was all addition. So obviously the lower one is going to be the one with the minus in it, minus 4 over n plus 4 over 3n squared is going to be less than our upper sum. And again, the only difference was that everything was plus in the upper sum. That looks ridiculous. A capital S on this one because it's the upper sum. Second, the difference between the two sums lessens as n increases. All right, so that little sentence right there, all it's telling you is if you increase your number of rectangles, the closer you're going to get to the area, which means those two, your upper and lower, are going to come closer together. Does that make sense? Does everybody understand that? So it's a better approximation. In fact, when you take the limits, as n approaches infinity, both the lower sum and the upper sum approach 8 over 3. And then we already know this. So the limit is n approaches infinity of your lower sum. It's going to be the limit as n approaches infinity of 8/3 minus 4 over n plus 4 over 3n squared. And then remember, we split those up and take each limit separately. So what's the limit of 8/3? What's the limit of negative 4 over n? And the limit of 4 over 3n squared. So it goes to 8/3. This is called the lower sum limit. You're going to do the exact same thing after this and, except for you're going to do the upper sum. So everything's going to look exactly the same. The limit as n approaches infinity, but of a capital SN equals the limit as n approaches infinity of 8/3 plus 4 over n plus 4 over 3n squared. It is the same exact limits, 8/3, but this time it's plus 0 plus 0, or 8/3, which is your upper sum limit. The next theorem shows that the equivalence of the limits as n approaches infinity of the upper and lower sums is not mere coincidence. It is true for all functions that are continuous and non-negative. On the closed interval a to b. So you always need to check that they're continuous and non-negative. So let f be continuous and non-negative on the interval a to b. The limit says n approaches infinity of both the lower and upper sums exists and are equal to each other. That is, the limit as n approaches infinity of the lower sum equals the limit as n approaches infinity of the summation from 1 to n of your minimum function times delta x. That's what we did yesterday. We're going to write the same thing. But this time it's going to be the max function times delta x. Which will equal the max function or the upper function. So remember that to find delta x, you do b minus a over n. And f of little mi and f of big mi are minimum and maximum values of f on the subinterval. So again, all it's saying is the limits should be the same. In theorem 5.3, the same limit is attained for both the min value or the minimum value, which is f of little mi, and the maximum value, f of big Mi. So it follows from the squeeze theorem that the choice of x in the ith subinterval does not affect the limit. This means that you are free to choose an arbitrary x value in the ith subinterval as shown in the definition of the area of a region in a plane. All right, so now we're going to find area by the limit definition, which is exactly what that block is. Everybody have all that blanks fill on this. Sorry. You good? Is everybody else okay? All right. So there's our formula right there, again with delta x listed out. So find the area of the region bounded by the graph of f of x equals x to the third, the x-axis and the vertical lines, x equals 0 and x equals 1. So what it's saying is you can pick any x's that you want. It doesn't really matter. So on this one, they picked 0 and 1. And remember, I told you that's going to be your a, b, or your interval. Remember that you're always going to check. If I look at this function x to the third, it looks like this, which means that it is continuous and it's positive or non-negative. All right, so to be able to figure out the area, we definitely need to know delta x. How do I find delta x? What is b minus a? I'm going to start my definition. Area equals the limit as n approaches infinity. And y'all, there's a lot to write here. All that reduction, that's the problem. All of that reduction. So I'll try to squeeze up as much as I can. Of the summation from 1 to n. And then we have this f of ci. Okay, just so you know, I think we went over this yesterday. Ci Jeez, I'm just kidding. Is a plus I delta x. What was our a? 0. Plus I, what's our delta x? Which simplifies just to I over n. Okay. The reason we have this, if I go back up to that formula, you guys see it says f of ci, right? Is everybody good? All right, so f of ci delta x this means plug that into the function. What was our function? X to the third. So we're going to do the limit as n approaches infinity of the summation from 1 to n. Of I over n to the third times delta x. Sorry, delta x is 1 over n. I'm not going to write all this juju in the front. We're going to go to the end. What is I over n cubed? And then times 1 over n would be not over n, but n. Look. You got to put the cube with both of them, right? Does everybody understand that? So yesterday we had a little problem with that. So I'm gonna go ahead and write it out. I cubed over n cubed times 1 over n would give me what? There you go. We're all in it together. It's all good. All right. So what did I have to do yesterday with this? What did I have to do yesterday with this? I got to do the summation, but what do I got to do before I do the summation? I mean, it is reduced. Tell me what you mean by reduce it. Look at that. Look. Is that what? Not yet. That's the summation part. What? Take out a constant. Thank you. Look at you. I hear you. What's our constant? It's not just n over, it's just not n to the fourth, it's what? 1 over n to the fourth. So anything like that, you just want I by itself is basically what you want. Okay, so I'm gonna take out 1 over n to the fourth. And then I'm gonna do my summation of I cubed. Right. There's a formula for that. Don't forget those formulas. So now we're down to the limit as n approaches infinity of 1 over n to the fourth. What's that formula for the summation of I cubed?
Squared times n plus 1 squared.
I just go ahead and multiply it all out. Okay, that's just me, and I'd rather do it that way than try to reduce and mess something up. Okay, so multiply it all out. N plus 1 squared, I'm just gonna write it above, is gonna be n squared plus 2n plus 1. So that we come down here, we're gonna distribute the n squared. So what am I gonna have on top? What am I gonna have on the bottom? Then we're gonna split those up. We're almost done. And remember, there are steps in this that you can skip, like I could have skipped this step that I just wrote. I just want you to know where everything comes from. We're gonna split it up into the fourth over 4n to the fourth plus 2n cubed over 4n to the fourth plus n squared over 4n to the fourth. Which reduces to the limit as n approaches infinity, also a step that you can skip because you can reduce this in your head. 1/4 plus 1 over 2n No, I did it myself. Sorry. I'm a dummy and did it myself. One over 4n squared. What's your limit of 1/4? 1 over 2n. 1 over 4n squared. So your area is 1/4. That's it.
Which one was the one we had to do like the left and right?
When they ask you to do the left and the right,
No.
or they ask you to do the minimum or the maximum. And again, the minimum and maximum depend on which way that graph is turned. Okay. Sorry. Is everybody good? That literally this, if you're understanding, like plugging it in and simplifying it, this section is easy. It's just a lot of work. Does everybody understand that? That's pretty much it. Okay. Look at the next one. It says find the area of the region bounded by the graphs of f of x equals 4 minus x squared. The more complicated the function gets, the more work you're going to be doing. Okay, so this one was easy because it was just x to the third. So there was no add, subtract, multiply, anything like that. So again, the more expensive the function gets, the more it's going to be work wise. The x-axis and the vertical lines 1, 2. What's that vertical lines tell us? 1, 2.
Didn't we end up finding areas of derivatives and stuff? Or is that a thing that you would have to-
Yeah. You figured it out. It is. Like your shell method and your washer method, you find an area of 3D or volumes of 3D figures. No, it doesn't.
We did
It doesn't. It's anti-derivatives. Everything's integrals in this. So this is going to lead into more things. Okay. All right. So I'm going to ask one more time. Vertical lines x equals 1 and x equals 2. What does that give you? Your interval. We always need to check. Figure this out for a minute. 4 minus x squared. Looks like this. And we're going from 1 to 2. So that's just this little function. It's above the x-axis, so it's positive. Everybody understand that? It's not a negative function. So we're good to go. So all we're looking at is this little bound part right there. Okay. All right, so it is continuous and non-negative. So we're going to continue on. What 2 things do I need before I even do the area formula? Remember, our area formula is the limit. You don't have to write this down. As the n approaches infinity of the summation 1 to n of FCI delta x. So tell me what are the 2 things we need to know? Delta x and CI. So how do I find delta x? B minus A over n, which gives us 1 over n again. How do I find CI? A plus I delta x. What's our A? 1 plus I. What's our delta x? So it equals 1 plus I over n. That also makes it more complicated. Everybody understand that? So then now we're going to start our area. The limit as n approaches infinity. Summation 1 to n. What does FCI tell us? Plug it into the function. So plug CI into the function. So our function is 4 minus x squared, and we're going to change x to 1 plus I over n. And then we have to multiply that by delta x, and our delta x is, how about I get it right? Our delta x is 1 plus, no, it's not. It's 1 over n. Sorry. I did have it right. All right. Did not put my other set of parentheses here, so I apologize about that. What do I do now? What do I do? Yeah, fix that parentheses first, put them together, then we can pull out a constant if we have one. So what do I have to do first? So I'm going to do this up here just so you guys can see it. What am I writing today? So we're going to multiply these. 1 times 1 is 1. 1 times I over n is I over n. I over n times 1 is I over n, which gives you 2I over n. Is everybody okay with that? And then IN or I over n times I over n gives you I squared over n squared. Is everybody okay with that multiplication? I just want to show you. All right. Equals the limit n approaches infinity. Summation of 4 minus all of that. You don't have to put your parentheses anymore, sorry. 1. But what I got to remember to do since it's a minus, distribute. So minus 1 minus 2I over n minus I squared over n squared still times 1 over n. clean it up some more, and you can go ahead and multiply your n on your denominator, and you can multiply to every denominator. So just to shorten it up, the limit as n approaches infinity, summation. What's 4 minus 1? 3, and then I'm going to multiply it by 1 over n. So you're just adding an n power to the bottom. I have negative 2i over n times 1 over n is going to give you n squared. And then I squared over n cubed. Because these all have different denominators, you're going to split it up and take the limit differently. Okay, so each individual limit. So when you do this, you'll take the limit as n approaches infinity of 3 over n, limit n approaches infinity of negative 2i over n squared. And you can make those minuses and make that a plus, that's fine. Limit of negative I squared over n cubed. So all separately. I don't mind, again, if you skip some steps, that's fine. If instead of writing all of this stuff, you want to take this and put it on a separate sheet of paper and draw it out, whatever, and then come back. So you can not waste a bunch of paper doing that. That's fine as well. What can I take out of this one? 1 over n. We're going to go ahead and do, I didn't put the limit in front, but we'll get there in a minute. I just didn't write limit. So we're going to go ahead and do the summation of 3 because I took out 1 over n. What's the summation of 3? 3. What's the summation of a constant? Constant times n, so 3 n, right? What am I pulling out of this next one? And I'm going to go ahead and make it minus for you guys, so don't worry about that. What are you pulling out? Okay. So y'all pulled out 2 over n squared. What's the summation of I? Mm-hmm. And n plus 1 over 2. What do I pull out of the third one? And then we're doing the summation of I squared. So what's the summation of I squared? N times n plus 1 times 2n plus 1 over 6. Is everybody good with all that? It's not too bad after this, I promise. All right. So what do you notice in the very first, just work on this first term. There'll be ends on the top and the bottom. So that leaves you with 3. So the limit is n approaches infinity. The first term gives you 3. We're going to do the second term right here. What do you notice? So split it up. What does that leave you with? What about this one? Yeah, but I'm going to go ahead. I'll tell you what I'm trying to do. N over n plus 1 over n. We'll go ahead and split it up. Does that make sense what I'm telling you now? Yeah. We'll talk about it in just a second. Remember, if we're trying to find the limit, we're trying to reduce it down anyway. So if you want to go ahead and reduce it at that point instead of using an extra line, that's all I'm telling you. But I want you to be able to see it too. All right, so let's look at our third term. It's going to be minus. Yeah, we can cancel out one of them. What's it give you on the top? When we multiply these, 2n squared perfect. So then what I'm going to have split up is 2n squared over 6n squared. Is everybody okay with that? Yeah. Then I'm going to have what? And then I'm going to have? Okay. Remember, you're almost done. It's all simplification from here, and then you know how to find your limits. So we're going to leave the 3. N over n reduces to 1. So when I distribute my negative, that'll be a -1. This 1 over n won't reduce, so it'll be a -1 over n. 2n squared over 6n squared reduces to what? And we're going to subtract 1/3. 3n over 6n squared. 1 over 2n. And then the last one is just going to be -1 over 6n squared. Perfect. Find those limits. What's the limit of 3? What's the limit of -1? What's the limit of -1 over n? The limit of -1/3. The limit of 1 over 2n. The limit of 1 over 6n squared. So there's what you have.
Pardon the interruption, teachers. I need Kirk Spurlock to come to the office, please. Kirk Spurlock to the office.
I've never heard that name. What?
Send everybody to these mass text.
Oh. Yeah, I don't understand why y'all add people y'all don't like or y'all don't know, or y'all are just
What did I
nosy.
say? I was like, oh, okay. Then in the streets every morning, every night, every evening.
Every time you walk in, you're
I unadded it.
I mean, we have new staff members, but I haven't added them on anything.
I mean, it does kind of suck that you have to move here. The senior year. It's kind of weird. Oh.
From where? Maybe they wanted out of the guns. Maybe they wanted out of the guns. Where'd he go to school? Winston's rough sometimes. Depends on where you're at. That's where he came from. I went to school. He said, no more.
I remember when Brian was the big kid.
All right, y'all ready? Next one. Next one. What's the difference in this one?
Got the signs in it.
Okay, so your interval is different because it's less than y, less than or equal to 1, which is fine. That's going to be your A and your B. Does everybody understand that? So all that says is we're looking at y between there. This y squared doesn't matter because if you look, your function is f of y, which is the same thing as f of x. They're just using a different variable. If they did f of r and they would have r squared, you would do the same thing. So find the area of the region bounded by the graph of f of y equals y squared, and the y-axis for 0 is less than or equal to y, less than or equal to 1. So what do we got to figure out? Delta y. Great job. Every day. It's okay. Here we go. Keep going. How do I do this?
B minus A over N.
B minus A over N. Oh, sorry, gives us 1 over N. What else do we need? How do we get CI? Very good. Which is?
Zero.
Yeah, it just said it, yeah. It's just saying for the Y between 0 and 1. So that's your interval. Yep. What was delta Y? Which reduces to? Is one going to be a massive one, or is it going to be a pretty easy one? Pretty easy. Your function's pretty easy. It's only one term, and then your CI is only one term, so it makes it a lot easier. All right, so now the limit. Again, approaches infinity of the summation from 1 to N of what? What is that? Mhm. I mean, we've done the same thing 14 times already. I mean, if you don't have it yet. Oh,
Yeah.
what part are you not getting though? Because you've not asked the question yet.
I don't know what
It's
it's.
like I don't even know what to ask. Yeah.
Yeah.
Okay, y'all, seriously, seriously.
It'll make sense in a little bit, but right now.
I
it's
know,
like that
but,
Charlie Brown.
okay, but ask, tell me what part you're not, just like KP asked, I don't even know where you got the B and the A from. That, y'all, somebody else had that question too, I can guarantee it. Okay, so our interval is the same regardless of whether they say it's X equals or Y equals 0 and 1, or if it gives you an inequality, or it says, here's your interval. Okay, so that's fine. Do you understand how to find delta Y? Okay, so delta Y is your interval, B minus A, your big number minus your little number, so that's positive, over N. So that's all we did.
That's up to Y.
In this one, it's delta Y, and the other one, it was delta X, just depends on what your variable is. Okay, don't screw that up, because if you screw it up, they might count off points on your final exam. All right, why are we finding CI? That's what we have to plug into our equation. CI is a formula. There is no variation into that formula at all. Okay, so where did A come from? Your interval. What was your beginning of your interval? 0. That's where the 0 comes from. This I is part of the formula. And then your delta Y you just found was 1 over N. Okay, so 0 plus I, 1 over N. And when we reduce it, gives us I over N. Is everybody okay with those two? Your formula, I didn't make it up. It's not anything crazy. Remember, is CI plugged into your equation? That's what that says. Plug CI into your equation. What is our equation down here?
Okay, I think that's where I was going.
Yeah.
I thought we were just making up.
Yeah, me
too.
Wait.
Y'all see how things are cleared up when you ask questions? All right, so your CI is 1 over N. When we plug it in, it'll be 1 over N squared. Then your equation says multiply that by delta X. In our case, it's delta Y. What is delta Y?
Man, I have been in the last 2 days, I've just been in the dark.
Are we good now?
And then you just multiply it out and simplify.
Yeah, girl.
That's a breakthrough moment.
Woo.
I feel like,
I felt like I was
I'm
just
surprised
sitting.
there's not a light bulb above my head.
I feel like it's still not on. We'll see.
Probably.
We'll see. We'll see. All right. So now, just simplify this. Forget everything in front of it. So how do we simplify this? I squared over N squared. Don't forget to distribute your square to both. Times 1 over N. I'm going to write the stuff in front. It doesn't matter yet. And I'm going to simplify it. I squared over n cubed. Remember, n is a constant. It's a constant. We want to get it out of the way. So we're going to pull it out. This limit is the very last thing that you'll do. So you just keep writing it till the very end. We're going to work with the summation part now because I did all of this. So now I'm going to keep moving back. Now it says do the summation. So how to do the summation? We got to get that n cubed out. And we're going to do the summation of I squared. That summation of I squared is a formula that you learned that I started and said, you need to memorize these. You need to know them. Okay. So now we can take off that summation part because we're about to do that. So the only thing we're going to have left is taking the limit once I reduce. So we have 1 over n cubed. The formula that they gave you for the summation of I squared was n plus 1, 2n plus 1 over 6. Forget the limit for a minute. We got to simplify all that before we take the limit. What? Yes, we can cancel out 1n. What's the top turn into? We just did that on the last one. Okay. So now I'm going to write them separately. So 2n squared plus 3n plus 1 is all I have on top. On the bottom, what do I have? Now, I'm going to work with the limit. I can still reduce a little bit, but I'm going to work with the limit as well. What happens to this first fraction? N squares cancel out, reduces to 1/3. What about the next one? Not yet. You're skipping a step. One of your n's cancel out. 3/6, this should be a plus, is 1/2. So 1 over 2n. On the last one, nothing will reduce. The limit stuff you should have. We've been doing it. What's the limit of 1/3? What's the limit of 1 over 2n? Limit of 1 over 6n squared, which gives us an area of 1/3.
I tell you, this makes so much sense now that I know this. Now that I know where we're coming from, just gotta make.
Do you have a for real question? Like,
Yeah, if we skip that, the step you did, like under the 2/6, was that like,
perfectly fine.
it's fine, like that?
Okay, I just need to clarify something before. As long as it's just like a number, it stays the same.
So remember, we talked about this in the last unit. If we had 1 over 2x and we graphed it, we're going to infinity. Where is this graph going to? It's not gonna, something is weird. It shouldn't look like that. Let me fix it. 1 over 2x. That's better. What are you doing? Graph. Now, it'll show it this way. Where does it go to? To 0. So that's why they're all 0. It's because anything underneath that 2 over n squared, 2 over n to the 8th is going to cause this. Does everybody understand that? So that gives us a 0. Is that right? Good. All right. A breakthrough moment there.
I just thought that if I kept on watching.
That's, you know,
I
that,
was trying.
and that is good in other classes because that will happen. But in this class, if you don't get it, you gotta I mean, we did like 4 examples before you asked where that CI stuff came from.
I get it now.
Everybody good now? Okay, we're about to do it again. Yay.
Well, you could,
Or we could keep going. In the last three examples, CI is chosen to be a value that is convenient for calculating the limit. Because each limit gives the exact area for any CI, there is no need to find values that give good approximations when n is small. For an approximation, however, you should try to find a value of CI that gives a good approximation of the area of the ith region. I think about Haley every time I write that now. In general, a good value to choose is the midpoint of the interval. How do we find midpoints? How do you?
You take the endpoint.
I knew we did. How you find it?
And then. Yeah.
You're not-
No, like, subtract the no.
You add it,
Am I?
divide
Yeah.
by two.
Thank you. You add them and divide by 2.
It was team effort. Don't just
I
give
was
her
thinking
all.
about the
I
same
help.
If you saw her face, you knew it wasn't a team effort. She was like, "You're an idiot." This is what it is. That was her face. All right. So are y'all ready? CI equals XI plus XI minus 1 divide by 2. What did you just tell me? To find the midpoint, you add the 2. Those are your 2 endpoints. Those are your 2 endpoints. So I'm gonna go back for just 1 minute, okay? I'm gonna go back to that problem that we took forever on. Remember when we had the right, we had 0 plus I delta X. When we did the left, we had I minus 1. That's exactly where it's coming from. Because to go left, you go backwards 1. Does everybody understand that? So all it's saying is the left and right endpoints of your intervals. That's it. Okay. So don't stress out about that whole X sub. It's just left and right. Okay. And then we divide them by 2 and apply the midpoint rule. Nope. All right. Okay, perfect. Thank you. Do you know how much effort it took to get up and answer that phone? Get out of here. Yeah, dude, you gotta go home. No, it said sign out and go home now.
Call him again. Call him back.
No.
If he calls me one more time because you don't get up and go, I'm making a 0 for a major grade.
Why do you gotta put that on the tape? Like, you don't gotta mention.
I'm really not, but he will probably call back. I just want to remind you I'm recording, just say. Yeah, we are almost done. All right. Sorry. All right, so we did not change this formula at all, except for your CI changed. So what we're changing CI to is instead of A plus I delta X, we're changing it to the midpoint formula. Okay, so it is the same process.
Is that -1 with the I?
Yeah, that's how, it's I minus 1, I know.
Yeah,
Isn't
just
it
like the midpoint formula up here.
I thought X I was.
Is it a subscript?
Yeah. If it were not a subscript, it would be next to it.
I couldn't tell.
They write it the same for 40 pages. Sorry, Philly. That's like Brian asked me what I wrote. What's it say? Like, no.
Why back mine?
Everybody always says show it.
Because you have messy writing. I don't know if
Your
anybody
writing
in
does
here.
not match your personality.
No, it doesn't.
Are you?
All right, last example. Use the midpoint rule. Shh. Use the midpoint rule with n equals 4 to approximate the area of the region bounded by the graph of fx equals sin x and the x-axis 0 to pi. What is something different that you see?
It gives you what n is equal to.
Oh, it gives you what n is equal to. So we've not had that, right? And yeah, it does give us pi because we're working with a trig function and we're working with sine. So that's still not different. It's still the same function. Did she say ooh?
Yeah.
You're just taking us up a little.
I don't like it. Oh, no, no.
Yeah, I got some Kleenex back there if y'all need it. I was crying. God. All right, sine is actually an easy trig function, is it not? Yeah, it's not like it's secant or, something that you're gonna have to find something weird, So it's pretty easy. So we're gonna use this midpoint rule. We do have n this time. So how do we split these into 4? Remember, delta x is still the same thing. B minus A over n. What was B? What was A? Over n. That's the difference. Calm down, everybody. So same formula, same thing, we just have an n this time. All right. So if I split 0 to pi into fourths, what are my endpoints? Where do we start? Do we start at 0? What's my next one gonna be? Pi over 4. What's my next one gonna be? 2 pi over 4 or pi over 2. 3 pi over 4. And then we finish with pi. So here's your 1 rectangle, 2 rectangle, 3 rectangle, 4. Does everybody understand that? What? I mean, that's how I felt today. Teaching baby children.
Hey, we're almost all 18.
Yeah.
They ask questions.
And that, I mean, is that supposed to like make me feel better?
Yeah, because we're like.
It's just, Miss Jones, it's in their bones.
All right,
Hey, don't even say
so are you ready?
that.
All right, so you have to find the midpoint of all of them. And then you have to find the summation of it. It sounds crazy, but it's not bad, okay? So it's actually less work than any other problems that we've had. I can promise you that. All right. So we need to find the first rectangle. So C1, the first rectangle. Remember, this is the midpoint. So our first rectangle, what are our 2 endpoints? So we add them. All right, I was thinking about adding. And divide by 2. You guys can do that in your calculator. 1/4 divided by 2 is actually 1/8, which will give you pi over 8. Keep it in terms of pi. Okay, so before anybody asks, how did I get that? What -1?
I thought there was one in the.
This is the left and the right endpoints. That's what that represents.
Okay.
So 0 plus 1/4 divided by 2. Math, enter, gives me 1/8. Keep it in terms of pi. So very good. That's where I got pi over 8. Your second rectangle, what are your 2 endpoints? So we add those and divide by 2, and we get 3 pi over 8. Third rectangle, what are your endpoints? And divide that by 2, and you get 5 pi over 8. Fourth rectangle, what are your endpoints? Divide that by 2, and you get 7 pi over 8. Realize if you split these into fourths, in the middle will be 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. Okay, you can do it that way as well, but I just want you to have all of the information, so if you get something weird, okay? All right, so now we found the area. Which is the summation from 1 to n of FCI delta x which is the summation. I'm doing this all at one time, and these are steps that you can skip. So this step and this next step. Sine of CI. Your delta x was pi over 4. So remember, we plug our CI into our function, right? So we had y squared on the last one. We plugged in CI for that y. Did everybody understand that?
Do we still put that as n, even though we have 4 now?
Yes. Is everybody good? All right. So we already have defined n, so you can put n or 4 interchangeably. It doesn't matter. If you put a 4 up there, it's not gonna hurt it. But what that means is we're gonna have 4 terms in our summation. What are those 4 terms from? The 4 midpoints, right? Everybody got that? So now your summation is gonna be that pi over 4 times, what does summation mean? It's in the word. What does summation mean? Means sum or add them together. Sine, what was your first midpoint? You're gonna add sine, what was your second midpoint? Plus sine, what was your third midpoint? Plus sine, last one. They don't want it in terms of pi or anything like that. They just do decimals, which is perfectly fine. Literally type it straight into your calculator. And you get 2.052. If you need to type each one individually, it doesn't matter, whatever you want to do. Any questions? What?
Terry's rocking.
No. Yeah. Is everybody okay? All right. All right, so listen carefully. Shh. Listen carefully. I'm going to give you just a couple problems from this that I want you to do while you're sitting here. Tomorrow, I will go over 5.1 and you will have time to work on the rest of 5.2. Okay, so page 299. We're going to start with 13, 15, 17. There will be more to this, so don't turn it in. Don't put it in the box. You're just going to add to it tomorrow. Everybody good?